All right, welcome back to another lecture, lecture 1.2. Before we dig into this one, I just want to uh, inform you of a couple things that might be helpful. So, first of all, we're going to be using a website called Art of Stat. So if you just type into a web browser artofstat.com, we'll be using the tools on this website to help us make histograms and bar graphs and calculate mean, median, and mode and all of that kind of stuff. If you're using this on your phone, I think they're free mobile apps that you can download onto your phone. But what I'm going to show in the lectures, and so what I would encourage you to practice with in the notes as you're going through the notes, are the web apps. So if you click on web apps right here, today we're going to be talking about visualizing categorical data. So we'll be using this tool, the Explore Categorical Data tool, a lot. In the next lecture, we'll talk about exploring quantitative data. But we'll be relying on these two tools pretty extensively in this entire first unit, all of chapter 1. But anyway, for today, we'll be doing exploring categorical data. And let me just show you real quick. So if you click on that tool, it'll open it up in a new window. And then it'll give some kind of annoying ad thing that you have to dismiss every time. But you have the option here of just looking at examples from whatever textbook this is based on, right? This textbook down here, that's not our textbook. But you could still look at these examples if you want. So that's one option. But if you want to enter your own data, then here in this menu where it says from textbook, you can click on the down arrow and you can upload a CSV file. That's basically like an Excel spreadsheet. You can put in a frequency table, or you can put in individual observations. Individual observations would be like raw data. And so here you can just type in whatever your raw data is. So you can enter values here manually, or you can copy and paste them from somewhere else. And so to make our work easier, what I have done is in the lectures back on Canvas, in the lecture kind of description, I will have the notes here that you can download and so that you can write on them and stuff. And as a reminder, you're going to be turning in those notes. But then I'll also have a spreadsheet that has all of the data in it. And so if I were you, I would go ahead and download this. Don't just open it up here in Canvas, because you're not going to be able to, well, I don't know, maybe you can copy and paste the data from here, but it would probably be better to just download the spreadsheet. So click on the little arrow next to it, and then you can open that up. And once it's open, there will usually be a little yellow ribbon across the top that you'll have to click on this button that says Enable Editing. So you click on that button, and now you can copy and paste values, right? Control or right click it and copy, and then you can come over to the app and paste it. So that way you're not having to type in a bunch of stuff. Anyway, so I just wanted to point that out to you. So if I were you, I would go ahead and have the notes downloaded or print it off if you don't have a tablet, and then also have the data downloaded so that you're kind of ready to go as we walk through this lecture. So without further ado then, let's dig in. So in the previous lecture, we talked all about how we can obtain data. We talked about just a lot of kind of terminology, but also how data is obtained. What we're going to do now is we're going to assume that we have some data, right? Somebody has obtained some data for us, and now we need to start to analyze it. So when data are first obtained, they're called raw data, right? And one of our goals in this chapter is to take a set of raw data and organize it so that it's easier to make sense of. The first stop along the way is to take raw data and transform it into a frequency distribution or a frequency table. Those are kind of synonymous terms. So for example, here is raw data, and this is supposed to represent the injury locations for a physical therapist, right? So this is like the injury locations of her patients. And what I've circled here is raw data. So the first patient that she surveyed had a back injury, and the next patient she surveyed had a neck injury, and so forth. And so this physical therapist just went through and recorded all of the injury locations for her patients and obtained this raw data here. As you can see, it's not easy to make sense of the raw data. It's just a kind of a jumble of words. And so a much better way to make sense of what we're looking at is to take that raw data and summarize it. And in this case, now it's been summarized into this frequency distribution, or this frequency table over here on the right. And you can see the frequency table is much easier to read, right? It's much more clear that, oh, like the majority of injuries were back injuries, right? There were 4 shoulder injuries, right? And so forth. So this is the first thing that we want to learn how to do. So let's talk a little bit more about frequency distributions and so forth. The frequency of an observation is the number of times that it occurred in the sample. The relative frequency is the fraction of times that it occurred. We sometimes call the relative frequency the proportion. And the symbol for the proportion is this symbol right here, which we'll read p hat. Okay? So p hat is x over n, where x is the frequency and n is the sample size. Okay, so for example, there were 4 shoulder injuries out of 30 injuries in total, right? So the proportion of shoulder injuries would be 4 over 30, right? Which you could convert into a decimal using a calculator or something. Okay, so a proportion is just a percentage expressed as a decimal. So it tells you the percentage of times that an injury occurred. So again, this is a little bit confusing. Sometimes students mix these terms up, so I want you to try to keep them in your head, keep them straight in your head as much as possible. The frequency is just the count of times that something occurred. It's the number of times that something occurred. The relative frequency is the proportion of times that it occurred, right? It's the fraction of times that it occurred. So, and I've already kind of done part of this. It says, referring back to the physical therapist data above, what is the frequency of shoulder injuries and what about knee injuries? So I'll let you give the video a pause and see if you can write down those answers. And then in part B, we're going to ask for the proportion of shoulder injuries and knee injuries. So again, give the video a pause and give it a try. Here are my solutions. So as far as the frequency of shoulder injuries is concerned, well, we already said that that was 4. And the frequency of knee injuries was 5. So for shoulder injuries, I'm going to say the frequency X of shoulder injuries, I'll label that with an S as a subscript, S for shoulder, was 5. And the frequency of knee injuries, I'll use a K as a subscript, that was 4, right? And then as far as the proportion is concerned, well, the proportion, p hat, of shoulder injuries would be 5 out of 30. I hope I'm getting those numbers right, or did I mix them up? I mixed them up, didn't I? Dang it. Okay, let me fix that. Shoulders were 4. There were 4 shoulder injuries and 5 knee injuries, so I better fix this up. 4. Okay. Now, if I want to change that into a decimal or something, then I can do that, right? So I'm going to use the Desmos calculator. So you go to desmos.com and then click on Scientific Calculator. And here I can just type in 4 out of 30, and it looks like that's about 13%. So let's write that down. So this is, whoops, leaning on my keyboard. Okay, so this is about 13%, 0.133. And notice that I'm using approximation signs because I'm rounding this. I don't want to write threes forever. Okay, and then the proportion of knee injuries, P hat there, would be 5 out of 30, which again, you can type into your calculator. 5 out of 30 is about 16.7%, 0.167. Okay. A frequency distribution, or in other words, a frequency table, is a table that lists each category of data together with its frequency. A relative frequency distribution, or relative frequency table, is a table that's going to list each category together with its proportion, or relative frequency. So the summary that we saw previously of the injury locations, that's a frequency distribution, right? It contains the frequencies. Okay, a relative frequency distribution would take those frequencies and convert them into proportions. Okay, to make a frequency or relative frequency distribution from raw data, we could go through and kind of manually do this by hand, but because we're human, we're not very good at this kind of thing, right? Computers are much better at this. And so we'll use the Explore Categorical Data tool from Art of Stat to do it for us, as I showed you at the beginning of the lecture. So let's do that, right? Example 2 says the data below represent the responses of 16 people who were asked what their favorite fruit was. So the first person asked said that their favorite fruit was an orange, and then the next person said apple, and then the next person said mango, and so forth, right? We're asked to use AOS, that's my abbreviation for Art of Stat, okay? So use Art of Stat to organize this raw data into frequency and relative frequency distributions, and then include your tables below. Okay, so let's, well, I'll let you give the video a pause and see if you can figure it out on your own. Otherwise, you know, you can follow along as I walk you through this first one. It's pretty self-explanatory, I think, but I'm going to exit out of this so that I can do it over again from scratch. So we want to go to artofstat.com, okay, and then click on Web Apps. And then under Web Apps, we're going to find the Explore Categorical Data tool. And I don't want to look at an example from the textbook. I want to put in my own individual observations. The name of the variable is not food choice. This is favorite fruit. And then I can paste the data here. So I'm going to open up that Excel spreadsheet that we looked at earlier. And I'm just going to take the data. I don't necessarily want to take the title of the data. I just want to take the data itself. Okay, so all I'm doing is I'm clicking on that first cell and then clicking, holding down and dragging. Okay, so I'm clicking and dragging, and then you can either right click and say copy, or you can hold down Control C on your keyboard, and then here we're going to paste it, right? So you can right click and paste, or you could say Control V to paste, right? So Control C to copy, Control V to paste. And here we go. We're given a frequency distribution in the first two columns, and then a relative frequency distribution in the first and third columns, right? We could just put the whole thing in there as our frequency and relative frequency table. You'll notice that it also makes a bar graph for us, which we'll talk about in a second. But let's give our tables. Let's write down our tables in our notes. So, okay. So we'll have a column for fruit, a column for frequency, the number of people who answered that fruit, and then a third column for relative frequency. And by the way, if you would rather use just the symbols for these things, right? The symbol for the frequency is X, and the symbol for the relative frequency is P hat. So you could just use the symbols instead. But let's see. For the fruit, we have orange, banana, apple, watermelon, mango, pear, peach, and pineapple. Now, you can include the totals if you want, but it's not necessary, okay? And then we can just copy down those frequencies. 3, 2, 4, 3, 2, 1, 1, and 2. And then the relative frequencies. And here, you can round to as many decimal places as you want. If you're doing a homework problem or like a test question or something, just pay attention. If it specifies like round to 3 decimal places or something like that, then obviously you need to round to 3. If it doesn't specify, then you're welcome to give as many decimal places as you want. Generally speaking, I will round to 3 decimal places on relative frequencies, so let's just stick with that for now. So this would be 0.167, 0.111, 0.222, and so forth. Okay, and that's how that goes in Art of Stat. Once we have if we were doing this by hand, we would have to get that frequency or relative frequency distribution first, and then we could use it to make a bar graph, right? So what a bar graph is going to do is it's just going to take our frequency or relative frequency distribution, and it's going to give it as a visual representation, right? So each bar is going to represent, in this case, we're looking at those injury locations again, but each bar is going to represent a different injury location, and those bars, the height of the bar goes up to, in the case of a frequency bar graph, the height is going to go up to the number of injuries for each of those locations. And in the case of a relative frequency bar graph, it's going to go up to the percentage of injuries, okay? But once again, Art of Stat will do this kind of thing for us. So example 3 here asks us to use Art of Stat to produce both the frequency and relative frequency bar graph for the fruit preference data from example 2. That's that example that we just were looking at. So let's see if we can get Art of Stat to do this. It automatically will generate a frequency distribution, you'll notice, right? So once we have that data in there from example 2, it automatically generates that bar graph. If we want, we could sort the bars in a different order. So we can move things around. That's not totally necessary. You can kind of play around with it. You can select different colors if you want, right? You can do all kinds of good stuff. So I would just encourage you to get in here and kind of play around with things. For example, we can label the bars so that the counts are given inside of the bar itself, which is really nice. We could draw it horizontally instead of vertically. Most importantly, we can give it titles and captions. So instead of just calling this thing bar graph, we could change that and call this favorite fruit. Or something like that. Anyway, so just get around there and play with things a bit. But this is how we get a frequency distribution. Now, we were also asked to give a relative frequency distribution. In order to do that, we're going to click on the little box that says plot percent. And so it changes. Right here we have a frequency distribution. When I click on this, it becomes a relative frequency distribution. And that's all there is to it. Okay. So as far as the stuff that we're supposed to draw in the blank space, well, just do your best. But on a test or a problem set or something, this is the kind of thing that you'll have to do, right? So we've got, I'm just going to kind of abbreviate. We've got orange, banana, pineapple, maybe I'll call it PI. And then counts, we go up to 4. 1, 2, 3, 4. 4, 3, 2, 1. Okay, so there were 3 people who said orange was their favorite fruit. There were 2 people who said banana was their favorite fruit, and so forth. And it, obviously we're humans, so we're not going to do a great job of this. That's why we have technology, but just do your best. One thing that you should absolutely do in a bar chart is you should leave gaps between the bars. You should not put them up against one another. There is a chart that we make where the bars have no gaps in between them. Those are called histograms, and we'll learn about those in the next section. But for a bar graph, there should absolutely be spaces between the bars. If you are asked on a test to make a bar chart and you don't leave gaps between the bars, you'll be marked down. Now, the other thing that you should do is you should give this a label, right? This is fruit. Down here, this is frequency. And then you should title the graph something like favorite fruit. If you want to be more creative than that, be my guest. But just give it some kind of title that describes what it is. Now, obviously, this is a frequency bar graph. As for the relative frequency bar graph, well, as we've seen, really the only thing that's going to change is that these things are going to become percentages. But the bar heights don't change at all. I mean, everything remains the same, right? The only thing that changes is just the y-axis over here. So you're welcome to try to fit that in into the notes, right? And put the other chart on there if you want. But I think you get the point, so I'll leave it there. Okay. One thing that we can do with bar graphs is we can compare groups. We can look at what's called a side-by-side bar graph to compare different groups of people. For example, a random sample of 2,163 adults aged 18 and over was asked, when you see an ad emphasizing that a product is made in America, are you more likely to buy it, less likely to buy it, or neither? The results of the survey are presented in the side-by-side bar graph below. So it's called a side-by-side bar graph because for each age group, we have different responses. And those responses are all kind of clustered together. So the blue bar here represents people who are more likely to buy when the product is made in America. The green bar represents people who are less likely to buy when the product is made in America. And the orange bar represents the people who have no preference, right? And so we have these clusters of 3 bars for each different age group. And so this way we can compare the way the different age groups respond to this question, right? Respond to products being made in America. So part A says, what proportion of 18 to 34-year-old respondents are more likely to buy when made in America? What about for 35 to 44-year-olds? So I'll let you pause the video and answer those questions. Okay, I'm going to go ahead and give my response now. So, what proportion of 18 to 34-year-olds? Well, that's this first group here, right? The 18 to 34-year-olds, these guys. So, and the blue bar represents people who are more likely to buy when made in America. So I'm looking for the height of this blue bar, which looks like it's about a little less than 45%, maybe 44% or something like that. So I would say for 18 to 34, the proportion is about 0.44, or you could say maybe 0.45. I mean, we're kind of eyeballing it, so it's okay to be off by a little bit. And then for 35 to 44-year-olds, theirs is a little bit higher. Theirs looks like it's a little bit more than 60%, maybe something like 61%. Okay, don't be too distressed if you said 60% or if you said 62% or something. You're still in the right ballpark. Okay, part B. Which group has the greatest proportion who are more likely to buy when made in America? Okay, I'm zooming out a little bit so I can see the whole chart on there. Which group has the greatest proportion who are more likely to buy when made in America? Again, that's the blue bar. So I'm looking for the group that has the tallest blue bar. And that looks like the 55 plus, right? They have the largest blue bar. Part C, which age group has a majority of respondents who are less likely to buy when made in America? Well, majority means more than 50%. So I'm looking for a group. Okay, and then also, like, the less likely to buy, those are the green bars. So I'm looking for an age group where the green bar is more than 50%. And there's only one age group that has that, and that's the 18 to 34-year-olds, right? And then finally, part D, what is the apparent association between age and likelihood to buy when made in America? Well, looking at this side-by-side bar chart, if we look at the blue bars, these represent the people who are more likely to buy when the product is made in America. And as you see the age groups increasing, the blue bars, the heights of those blue bars are also increasing. So I think the older you are, the more likely you are to respond positively to a product being made in America. Conversely, we could look at the green bars and we can see the older you are, the shorter the green bar gets, right? The green bar are the people who reacted negatively to the product being made in America, right? So I think the older you are, the less likely you are to respond negatively to a product being made in America. So we have two different ways of saying the same thing, right? We could say, well, the older you are, the more likely you are to respond positively to a product being made in America. And the older you are, the less likely you are to respond negatively to a product being made in America. So you could write down whichever of those you prefer. I'm just going to say the older a person is, the more likely they are to respond positively Let me try that again. Respond positively to a product made in America. Okay. One more example. I think this is the last one in these notes. It says the data below represent the educational attainment in 1990 and 2023 of adults 25 years and older who are residents of the United States. The data are in thousands. Okay. So we can see in 1990, there were, so 39,344 really represents 39,344,000, right? In other words, each of these numbers, you should really add 3 zeros to the end of it, but that's fine. So we can see in 1990, there were a lot more people who had not earned a high school diploma than in 2023, right? And so forth. So let's see if we can answer some questions. It says, use Art of Stat to do parts A and B, then answer the questions in parts C through E. Okay, so I'll let you pause the video and give this a try. Part A wants you to construct a relative frequency distribution, and then part B wants you to draw a side-by-side relative frequency bar graph. Those are actually done simultaneously in Art of Stat, so I'll let you do that. And then we'll check back in and go through parts C through E. So let me just pull up those graphs. Let's pull up those graphs and go through them together. Okay, I'm gonna pull up a new, a fresh page, right? Exploring categorical data. The data that we want to look at is actually, we've got two groups, right? We've got two groups that we're going to be comparing. So I'm going to go up here in this menu where it says one categorical variable. I'm going to go over to two categorical variables. And once again, I don't want to do an example from the textbook. What I actually have is a table. I don't have raw data to enter. What I have is a table of observations. They call that a contingency table here, and we'll talk about contingency tables in a little more detail later. You can see that it has a little table here, row 1, row 2, column 1, 2, 3. In our table in the notes, it looks like we have 1, 2, 3, 4, 5, 6 rows and 2 columns. So let me make that 6 rows and 2 columns. Row variable name and column variable name, you can change those if you want. Our row variable is educational attainment. And our column variable is year. Okay, you could also change the row names if you want. In fact, here I think it's helpful to do so. So this is not a high school grad. High school grad. I'm having trouble typing because I have a band-aid on my finger. Anyway, some college, and it's messing me up. Associate's degree, I'll just abbreviate that. AD. Bachelor's degree, BD. Why does that keep happening? BD, okay. And then graduate degree, GD. Okay. And then for the years, we'll put 1990 and 2023. And then we could just enter the values, right? 39,344. By the way, actually, we do have these in the same spreadsheet. So down here at the bottom of the spreadsheet, you'll notice that there are different tabs. We have the favorite fruit example that we already did, and then we have the education example here in the next tab over. I'm just going to copy and paste. Oh, don't do that. It puts them all in the same row. That's ridiculous. What if I do it like this? No, same thing. Well, shoot. I guess I am going to have to manually enter them in. So take your time. Make sure to double check that you got all numbers in there correctly. Okay, yeah, that looks good. So we were asked to construct a relative frequency distribution. Well, actually, we need to fix this up. So we don't want the conditional distribution by rows. In other words, when it says by rows, what it's doing is it's taking the 39,344 and dividing it by the row total, 63,861. But that's not really what we want. What we want is the percentage of people in 1990 who didn't have a high school diploma. So we want to take the percentage in 1990 and divide it by the total number of people in 1990, right? So we don't want to do this by rows, we want to do it by columns. Okay, that's better. Okay. So now we can see that in 1990, about 25% of people did not have a high school diploma. About 30 people were high school graduates. About 19% of people had some college, and so forth. Okay, and we can compare that to the distribution in 2023, right, and how different it was. We also are given a side-by-side bar chart here. We have these side-by-side bar charts now where we can make different comparisons. We can kind of see, oh, the pink bar over here in 1990, is much taller than the pink bar over here in 2023, right? So there were a lot more people who are not high school graduates in 1990 than there were in 2023, right? Which is probably good news. Anyway, let's see if we can answer some follow-up questions. So, part C says, did the frequency of people who earned a bachelor's degree rise or fall from 1990 to 2023? What about the proportion of people who earned a bachelor's degree? Okay, well, for the frequency of people who earned a bachelor's degree, we can just look at this chart that we have right here, right? In 1990, the frequency was 39,344. In 2023, it was 24,517. So the frequency decreased, right? It fell, right? The frequency. Oh, I'm sorry. I was looking at not a high school grad. We should be looking at bachelor's degrees. So bachelor's degrees in 1990 versus 2023, that rose, okay? The frequency rose. What about the proportion? Well, for the proportion, we'd have to look at that graph or this distribution that we just made. The proportion of bachelor's degrees holders in 1990 versus 2023, that also rose, right? That also rose. So we can say the proportion also rose. Part D asks a similar question. Did the frequency of people who had some college rise or fall from 1990 to 2023? What about the proportion of people who had some college? So this time we're looking at some college. That's this one right here. So the frequency rose. Okay, we went from 29,780 to 34,805. So the frequency rose. What about the proportion? Well, let's look at our graph or our frequency or relative frequency distribution. So the proportion of people who had some college in 1990 was about 18.7%. In 2023, it was about 16.8%. So it fell, right? It fell a little bit. Okay, the frequency rose, but the proportion fell. Okay, that's interesting. Part E says, based on your answers to Part D, is it better to compare frequencies or proportions in this case, and why? Okay. Yeah, because if we compare frequencies, then we would say, oh yeah, the people who had some college, it rose from 1990 to 2023. But if we look at relative frequencies, we would say it fell, right? So what's better? Well, notice that we don't have the same number of people in each category. There were about 158,000 to 206. So there's like 50,000 more people in the survey from 2023 than there were in 1990. 50,000. So it's possible that you could have a situation where the number of people in 2023 is higher than the number of people in 1990, even though they make up a smaller share of the overall number of people in 2023 compared to the overall number of people in 1990. Which is sort of a long-winded way of saying, like, it's much better to look at proportions. Whenever you're comparing groups of different sizes, like these two groups, it's always better to compare proportions or percentages than it is to compare counts or frequencies, right? It's better to compare proportions because the groups are not the same size. Okay, so that'll do it for this lecture, and I will check in with you in the next one.